Hello, I hope you're all well. One of your classmates asked me about problem 117 on page 86. Here's the problem. You want to convert the square root of t into t to the 1/2. Multiply your exponents, you end up with t to the 1/2 t. Take the natural log of both sides. That enables you to put the exponent in front of the natural log of t. So the derivative of natural log of y is 1 over y, derivative of y prime, 1/2 natural log of t plus 1/2 t, derivative of the natural log of t is 1 over t. They cancel, you end up with 1/2. So y prime is equal to y times 1/2 natural log of t plus 1/2. Substitute in this value up here for y, and that's your answer to the problem. You have access to the solutions manual. Sometimes in the solutions manual they don't put in some hidden steps. All right, once you turn to page 97, number 10, we're going to do separation of differential equations. The derivative of a function, in this case, depends on the value of x and the value of y. Y is going to be greater than 0. So what you want to do is you want to bring the y to the 1/2 to the other side, which makes it y to the negative 1/2 dy x squared dx. Looking for, so you take the integral of both sides, you're going to get 2y to the 1/2 equals 1/3 x cubed plus c. Now there should be a plus c on both sides. The mathematician will tell you C1, C2 plus C2 going to equal C. You don't know what it is, they just put down a C. And C will be equal to this. So this is your answer to that problem. Try number 12. Pause the video and try number 12. All right, so I want to bring the e to the negative y to this side. It's going to become e to the y dy, 3x squared dx. Integrate both sides will give me e to the y plus c sub 1. I put the c's in this time. And it's going to give me x cubed plus c sub 2. Well, c sub 1 plus c sub 2 is going to equal c. Since we don't know what it is, we can write that. And c is going to be equal to e to the y minus x cubed equals c. Questions? Do you have any, please? All right, I want you to turn to page 97. There's a formula on page 90 which is explained. It says y sub 0 is the initial value, y is the value you have at the end, e, k, which is the constant rate of change, t is time. If k is greater than 0, you have increase. If k is less than 0, you have a rate of decay. So let's take a look at problem number 23 on page 97. All right, for problem number 23, it says y, the original amount, the end amount to be 99% of the original amount. All right, so we're going to use this formula here. They will give us t, we have to find k. So at the end you have 99% of y sub 0, the initial amount, equal the initial amount times e to the kt. Divide both sides by the initial amount, you get 0.99 equals e to the kt. They tell you that time is equal to 1,000 years. 0.99 equals 1,000 times k. Take the natural log of both sides, you're going to end up natural log of 0.99. This, by properties of logs, is going to give you 1,000 times k. K is equal to natural log of 0.99 divided by, I should have that k there, divided by 1,000, that'll give you negative 0.001, 1.005, so on. We will truncate it to 0.00001. All right, take a look at part C. I'm sorry, I meant to say take a look at part B. All right, there's the formula for it. What you want to do is you want to calculate it for t. This is the value for k. Just make it negative 0.00001. Forget the rest of it. Give that a try, and I will erase the board. All right, I have y sub 0 divide through the cancel each other, so it's 0.9 equals e to the kt. Take the natural log of both sides. By properties of logs, this is going to be equal to kt. So I have the natural log of 9/10 equal to kt. K from the previous problem is natural log of 0.99 divided by 1,000. So the natural log of 0.9 divided by natural log of 0.99 divided by 1,000 equals t. And you do the arithmetic and you will end up with 10,483.28 years. All right, if you take a look at problem 25, it says dy over dt equals negative 0.6y, which is a linear equation. This is the rate of change, which means that is the k. You can go through and integrate it and find that you'll end up with y is equal to y sub 0 e negative 0.6 times t. So substitute it in, well, go ahead and do it. Y sub 0 equals 100. Go ahead and solve it. Pause the video, see what you do. All right, so you end up with y is equal to y sub 0 e to the negative 0.6 t. Tells you y sub 0 is 100, t is going to be 1 hour, so you substitute them in, and after 1 hour you're going to have 54.88 grams. Let's take a look at problem number 26. I'll put it on the board. You try it at your seats. All right, just plug into this formula the information they give you. All right, they tell us that at the end you're going to have 800, start off with 1,000, e to the kt, and they tell you t is equal to 10 years. All right, so divide, the 4/5 equals e to the 10k, take the natural log of both sides, solve it. So natural log of 0.8 divided by 10 is equal to k. Now plug that into the second part of the question. All right, now they're using a for y, meaning amount. So this would be the final amount you have, the initial amount. The initial amount is 1,000, it's e, you put in the k, multiply by 24 because it's 10 years. You notice in the problem at the bottom it says after another 14 hours. So it's 24 hours. You do the math here, you end up with the amount is equal to 585.35 kilograms. All right, let me put your homework on the board. Now when you do these problems at home, stop the video, pause it, try it, see how you do. Put on the video, check it. You also have access to the solutions manual. Okay, here's your homework, page 97, numbers 9 through 12, number 23, 25, and 26. All right, if you have any questions, please email me, but email the question to all the students. Use the Blackboard email. That way I don't get repeated questions. Thank you. I hope you're all well. One other thing. I haven't figured out what to do with the tests yet. Pearson wants me to do them online. All right, and I will try to put up videos as often as I can. And what you want to make sure you're doing is you try the problem, then check the video. Or look at the video, pause it, do the problem over. Don't just look at the video and say, oh, I can do that. Comes to the test, you're not going to be able to do it. And don't forget, as I said, you have the solutions manual online.